You're listening to Spacetime with Stuart Gary.
Over 15,000 potentially deadly near-Earth asteroids have now been discovered by astronomers. Researchers, mostly funded by NASA through either the Catalina Sky Survey in Arizona or the Pan-STARRS project in Hawaii, are now detecting something like 30 new asteroids in near-Earth orbits, so-called near-Earth objects or NEOs, each week. A near-Earth object is defined as an asteroid or comet with the potential to impact the Earth. NEOs have orbits which periodically bring them within about 195 million kilometres of the Earth. That equates to about 1.3 astronomical units. An astronomical unit being the average distance between the Earth and the Sun, which is around 150 million kilometres. The number of catalogued asteroids now known to be approaching Earth has grown rapidly since the count reached 10,000 only 3 years ago. The discovered NEOs are part of a much larger population of well over 700,000 known asteroids in our solar system. Astronomers estimate they've now found, they think, about 90% of all the NEOs larger than a kilometre. However, they think they've only found about 10% of asteroids in the 100-metre range and only about 1% of all the asteroids in the 40-metre range. The European Space Agency's Space Situational Awareness Programme in Italy will combine new NEO discoveries with existing European telescope data for all objects for which an Earth impact probability can't be ruled out. ESA astronomers were instrumental in imaging and then confirming the orbit of asteroid 2016 RB1, which grazed the Earth on September the 7th this year, passing just 34,000 kilometres above the ground, lower than the orbits of many satellites. So, why is it important to keep an eye on asteroids in our neighbourhood? Well, as any dinosaur can tell you, asteroid impacts have the potential to wipe out most life as we know it. Scientists are fairly sure that some 66 million years ago, a giant space rock, an asteroid about 10 kilometres across, slammed into the Earth, causing a mass extinction event that killed over 70% of all life on the planet, including all the dinosaurs larger than birds. Their demise led to the rise of the mammals and, of course, eventually humans. The jury is still out on whether that was a good thing. The smoking gun evidence for the so-called KT boundary event asteroid impact comes from a massive 66 million-year-old crater in what is now Mexico's Yucatan Peninsula. That crater was generated by a 10-kilometre wide asteroid slamming into the planet at over 50,000 kilometres per hour. The asteroid raised temperatures to around 5,000 degrees Celsius as it burst through the atmosphere. Hitting the planet at an angle of 30 degrees, its impact vaporized 1 trillion tons of Earth in a second, in the process creating the 180-kilometre wide, 10-kilometre deep Chicxulub crater extending way out into the Gulf of Mexico. Any living thing within sight of the impact was killed instantly either by the heat of the impact itself or by the actual blast shock wave caused by the asteroid. A tsunami several kilometres high was generated by the impact, flooding what is now the Americas, Africa and Europe. Within minutes, the impact sent a searing vapour cloud of poisonous gas spreading over North America, killing almost all life. Burning ejecta from the impact crater was thrown high into the upper atmosphere, eventually raining down as fire over the entire planet, and starting global firestorms which incinerated entire continents. The dust from the impact and smoke from the subsequent firestorms blanketed the entire planet, blocking out sunlight and heat, and creating an impact winter which lasted for months if not years. This cosmic collision is called the KT boundary event because it marks the delineation between the Cretaceous period, before the impact, when dinosaurs still ruled the world, and the Tertiary era which followed. In fact, there's even an actual KT boundary line which covers the entire planet, a dark iridium-rich layer between the Cretaceous and Tertiary. Iridium's a very rare mineral on Earth, but it's common in asteroids. This was the 5th mass extinction event in the Earth's geologic history. Interestingly, scientists believe that had the KT asteroid hit the Earth just about anywhere else, the dinosaurs would probably have survived, and humans probably would never have evolved beyond tiny shrew-like mammals. That's because the exact spot where the asteroid hit contained massive amounts of gypsum. As this gypsum was vaporized by the heat of impact, it produced a toxic mixture of chemicals including sulfur dioxide and the greenhouse gas carbon dioxide. The sulfur compounds were especially toxic, forming little globules that persisted in the atmosphere for up to 100 years. The sulfur also mixed with seawater which was vaporized by the impact to produce a powerful sulfuric acid rain which would then have fallen over the entire planet. So, in addition to a nuclear winter-type global cooling, the planet and all life on it would have also been choked on carbon dioxide and suffered showers of caustic acid. And the one thing all astronomers are certain about is that another asteroid impact on Earth isn't just likely, it's guaranteed. The only question is, when?